This is really fun. We're going to dive deep into the .git folder. I have no slides at all, and so this will be only live demos. It will be so much fun. We're going to create some Git history, and then we're going to open the .git folder, and we're going to look at what every file in there does. We're not going to hit all of the commands within Git, but we will look at all of the files in the .git folder. So this is really cool. The code for today, all the demos that we're going to look at, is here on this GitHub gist, and that URL is heinously long. So let's head off to robrich.org, robrich.org. Click on presentations up here at the top, and here's the definitive deep dive into the .git folder. The content is online right now. Have you ever found a speaker who said, I'll definitely post my slides on my site tonight? Yeah, how'd that work out? It is online right now. Achievement unlocked. Woo! So while we're here on robrich.org, let's click on About Me and we'll see some of the things that I've done recently. Thanks for the introduction. Microsoft and Docker have each given me some awards. I work for a local global nonprofit. And some of the other things that I've done, AZ Give Camp is really fun. AZ Give Camp brings volunteer developers together with charities to build free software. We start building software Friday after work. Sunday afternoon, we deliver that completed software to charities. Sleep is optional, caffeine provided. If you're in Phoenix, come join us for the next AZ Give Camp, or if you'd like a Give Camp here in Salt Lake, or wherever you traveled from, find me here at the event. Hit me up on all of the socials here on the top right. And let's get a Give Camp in your neighborhood too. Some of the other things that I've done, I got to work on a couple of books. I run some user groups. And one of the things I'm particularly proud of, I replied to a .NET Rocks podcast episode. They read my comment on the air, and they gave me a mug. Woohoo! So there's my claim to fame, my coveted .NET Rocks mug. And if you'd like a .NET, no, I'm just kidding. So let's talk about Git. I have here a Git folder, and it is completely empty. So let's create some stuff here in the Git folder. Git init. Now, oftentimes when we create a Git repository, we'll clone it from GitHub or GitLab or Bitbucket, and we're not going to do that yet, but instead we'll just create a new Git repository. Now what that did is it created this .git folder. Now, by default on Windows, this is hidden. On Mac and Linux, it starts with a dot, so it's hidden. So I came in here to view, I said show options, and I said show hidden files and folders, and thus I could see it. So this .git folder is the cool stuff that we're going to look at today. So let's open that folder up in VS Code. Now I'm not going to open the folder that it contains in VS Code, but rather the .git folder itself, because by default, VS Code will hide it from us. Cool. We've got a refs folder. We've got some stuff in there, an objects folder, some stuff in there, info, hooks. That's got some stuff. And so that's the .git folder. Any questions? No. Let's start creating some stuff. I'm going to say echo file1 contents, and I'll redirect that to file1.txt. I'll git add file1 into my staging area, and then I will git commit -m adding file1. Am I supposed to call that initial commit? Is that like a thing? Okay, so we've got some content now in our .git folder, and what we can see now is that here in our objects folder, we have a whole bunch of stuff. Now, let's do a git log, and we see we have 0C, C1, D2, C04, F3, BA, 00, C7, 00. I love going to my boss and saying, hey, can I deploy the latest version? And they're like, well, what is it? Hold on. E0063, FC2, but what's the FC, F26? This is a hash of the parent node's hashes and the hash of the content that we committed. And what's really cool, 0C, C1, is in the 0C folder, C1D2. The way it organizes our commits is the first 2 digits is the folder name, and the rest of it is the file name. So let's pop open that file, and there's no extension to this file. There you go. There's all the content. It's actually zlib compressed, so let's figure out how we can unzlib compress something. Okay, so off to the interwebs, and let's take a look at how we can use AI. Let's take a look at how we can zlib decompress stuff. Oh, OpenSSL, that's a cool use of OpenSSL. We could look at Perl, we could use Python. Here's a way to do it with LS files, that's pretty cool. And here's a C program. I wrote myself this little program that I call unzipper. And let's take a look at unzipper. Unzipper is this node module that just basically grabs the zlib library and uncompresses it, inflates it. So let's unzipper one of these commits. Git log unzipper, and I'll go into the .git folder in the objects folder. I'll look at 0C and C1, and let's see what's in it. Oh, hey, that looks familiar. All of the commit details that we had in git log, the username, the email. Remember when you said git config -- global user.email and user.name? Yeah, just pulled those into here as the commit details. Oh, and we've got this tree node. That's interesting. It says 186. There's 186 bytes in this whole message. But this tree node, AD88, that tree node, AD88, that's right here. That's pretty interesting. So let's take a look at that tree node. Let's unzipper AD88. And that tree node has some interesting stuff. That tree node is actually double zlib compressed. But we can see that we have a third node here, this F3. So let's unzipper that one and take a look at F3. And there's the contents of our file. Now this is a blob node. We can see that that's the blob node here. It has 16 bytes in it. Here's the 16 bytes from our file. And so then the tree node contains that. That's what this thing is the hash off to that file. And then the commit node references the tree node that then gets us to the content. So let's actually do that a little bit different. Git ls files, git log, git ls files, 0cc12, nope, not git ls files, git cat file, -p 000cc1d, and that says here's the contents of it. We could also do git cat file -t, which will give us the type. So it is of type commit. That's cool. And the commit details are right here. We pulled out the tree nodes. So let's git cat file -p or -t AD88, and we see that that's a tree node. If we do -p to look at the contents, because apparently content starts with P, then we can see there's the contents, and it actually says, here's the Unix permissions on it, here's a blob, and here's the blob for it, and here's the file name that I called it. Git cat file -t, that commit, it is of type blob. And if we switch to -p, we can take a look at the contents of that file. That's cool. So here in the objects folder, we have 3 different types of objects. We have commits, trees, and blobs. Well, let's commit some more content. Echo file2, I'll redirect that to file2, git add file2, git commit -m, adding file2, And now we have a couple more things in our objects folder than just those three. We have three more: a new commit node, a new tree node, and a new blob node. Yeah, we could spend a lot of time cat filing things, but I actually built this project Git Explorer to be able to take a look at this. Now, the cool thing about Git Explorer is that we're not just looking at commits, but we're looking at tree nodes and blob nodes too. So let's pop open Git Explorer in this repository and take a look at the content there. Oh, let's start Git Explorer. There we go. Git Explorer would like to tell us the stuff in our repository, and it's still compiling the TypeScript. There we go. So we've got some nodes here. Now, I wanted to look at this new node here that we just built. Git log one line 860. So let's go find 860 over here. There we go. There's 860, and it references this tree node 91. Well, actually, let's do this, and we'll add some details on it. So 860 here is a tree node, and a commit node, and it references this tree node 91. So we can look at that. Let's show that type so that we can see it. Okay, so red is the commit nodes, and blue is the tree nodes, and green is the blob nodes. So here's that commit, and it references this tree, which happens to have two files in it. And here's the two files. Here's file 1, and here's file 2. That's kind of fun. We can now kind of cruise through our repository looking for interesting things. So when we look for things like, well, what's a really big commit? Well, a commit is all of the commit things. It's that node, and it'll reference a tree node. A tree node might reference one or more tree nodes, probably more blob nodes, and blob nodes have the actual thing, so I kind of have to navigate through. So when you say, what is a big commit? That's why that question is hard. Well, let's, instead of doing it alphabetical, let's do it as a parent-child thing and show some lines, and now we can say, okay, so here's the main commit, and its parent commit is this one. And at that stage, I had only one file, and it was this file. And then when I got to here, I added a second file, and it was this file and this file. So we can see that we reused that existing blob. That was cool. Let's commit something else. Git, echo file 3. Let's redirect that to file 3. Git add file 3. Git commit -m file 3. And we'll refresh our graph. What did we get? Well, we got one more commit. Let's do parent-child, show the lines, show the tags, show the type. And so now we have this new commit that now references this tree node that says I now have 3 files in my directory. Here's each of those 3 files. And so we can do that. That's cool. Well, what if we add a folder? Okay, so let's go create a folder. I'm going to apparently open, apparently I have to create a firewall rule to create a folder. mkdir folder, echo file 3 into folder /file3.txt, git add folder, file 3, git commit -m, file 3 in a folder, and let's take a look at what happened here. Okay, let's show the type, parent-child, show the lines, show the tags, and so I have a new commit, and it references this tree node that happens to have 3 files in it and 1 folder in it. This is the folder file, and it has file 3 in it. And you notice that we still only have 3 blobs. We didn't change the thing. We just referenced it from somewhere else. So if I change the file and you rename the file, Git can solve this. Git doesn't need to worry about, well, what happened here and did we drop and recreate? Nope. If I change it and you rename it, Git can merge it just fine. Well, let's do that. Let's come change a file. Now, we're coders here, so let's open up this Git folder. And we're at a JavaScript conference, so we need lots of semicolons and some curly braces and some uncurly braces, and they aren't even. And so let's define undefined equals defined now, because that's awesome. Let's add some code. Okay. Git add dot, because I'm not paying attention. Git commit -m, changed stuff. Show the type, parent child, show the lines, show the tags. Here's my node, that looks great, I changed stuff. Here's the folder, and it looks like I've got those things. I have this file 3 that is new, and oh, I accidentally committed a secret here. Now there's also something interesting here. I modified the file, but what I have in my blob is the entire file, not just the changes to the file. You can see that line 1, file 2, is right there at the top. It stores the entire file every time. So how does it do a diff? It compares this one with the last blob. That's pretty cool. So I accidentally committed a secret. It's 5 o'clock, it's Friday, I just want to go home. Can I just not? Oh, I know. I can go commit the opposite of that. Let's open this file and let's delete the secret. And I'll just recommit it. Git add dot, git commit. Oh wait, if I commit it, then it's still going to show the old one in my commit history. But I learned about this thing called amend, so let's do that. Change stuff, nothing to see here, and amend. Oh. Apparently spelling is hard. Okay, so we just amended the commit. That commit was no longer there anymore. It's now better, right? Show the type, parent child, show the lines, show the tags. So here's my new commit, and it references this tree node, and it references this blob node. Oh, look, my secret is gone. Excellent, right? Here's that commit, tree node, blob node. It's still there. Git is a really good double entry bookkeeping system. And so once you put it in Git, it is in Git. Yeah, in 2 weeks it might find stale branches that don't have references pointing to them anymore, and it might do a garbage collection and it could clean this up. And yeah, maybe I didn't push it yet, but I don't know, a couple of weeks ago I found this really cool option in VS Code that allowed me to auto sync. Let me actually open this repository right here. There's this cool thing in here where I can say auto pull, and it will actually, oh, there we go, sync, and it will automatically do this on a schedule. So yeah, I didn't push yet, but my content may have left my machine already. There's a similar option inside of Visual Studio. There's a similar option inside of SourceTree. I can get it to automatically push my branch. So my secret may have left my machine. It probably hasn't gotten garbage collected yet. I know it's 5 o'clock. If you committed secrets, that secret is lost. You need to rotate your keys. Any questions or thoughts or concerns so far? Yeah. If you commit a secret, it is gone. Rotate your keys. Okay, so we did some interesting commits and stuff, and we saw how all of those were here inside the objects folder. That was really cool. Let's take a look inside of the refs folder. Now we have this ref called main here, C256. We saw that before. That was one of the commits that we had. Git log -- one line. We can see that there's C256. Oh, so this head, the main branch, points to this commit. And in fact, there's a head that, of course, is not inside the refs folder for reasons. And it says head, the working directory, points at refs heads main. Cool. And main points there. So let's say git log. If I would like main to, I don't know, point to here, let me change it to point to there. And now if I do a git log -- one line, I can see that main is over there. Let me do -one line -- graph -- decorate -- all. Oh, so I just moved it and it's like, okay, I'm done. There's no more branches. Well, the only way to break Git is to change stuff in the Git folder. So let's not. Let's put that back, and main is now where we expect. But these are just name tags. They're labels. They're human-readable things that allow us to do interesting things. So we've got main, and it's pointing at this particular commit. We've got head that's pointing at here. Let's do something interesting. Let's git checkout that. I am in a detached headspace. So how did I enter this zombie-like environment where I'm now in a detached headspace? Well, what it's telling us is that head no longer points at a branch. Now I can still do all the things. I can say echo file4, redirect that to file4.txt, git add file4, git commit -m file4. Everything still works. Git add. Oh, there we go. Git log -- one line -- graph -- decorate -- all. And everything still works, but main, or head rather, no longer points to main. Head points to a commit. So if we were to say git checkout main, then we're lost. That branch is no longer accessible. Git log -- one line -- graph -- decorate -- all. That commit is just gone. Well, is it gone? Git stored my secret forever. How do I get back to that commit? Well, let's take a look at the ref log. Now we're here in the refs folder, and so we can open up the logs folder and take a look at refs heads main. Here's where main was. It started out at nothing and it went here. Then it went from here to here. Then it went from here to here and from here to here. And there's one for head and it went from here to here. And so I can now see where head was, and it looks like I want this one. Git checkout that. And now I'm back to where git ref log. This is a better way to browse it. So I was here, and then before that I was here, and before that I was here. So let's go git checkout that. And now we're back. Now I'm back in that detached head space, and we know that detached head just means that we are pointing at a commit rather than pointing at a branch. So let's go create a new branch. Git checkout -b, new branch. And now we are no longer in a detached head space. We have our head pointing at a specific branch, and now Git is happy. Cool. So that detached headspace message was kind of scary, and it did want to help us get to a more safe place, but it isn't the spot to just destroy everything and start over. It was okay. So inside the logs folder, we have refs that allow us to get back to it. And we can see why this is refs heads new branch, because inside the refs folder, inside the heads folder, is that new branch. Well, we can also create tags. So I can say git tag v0.1. And now there's a tag associated with this branch. And that tag happens to be in the tags folder, and it points at a commit. Now, tags don't usually move, so pointing it at a branch may not make sense. So we'll point it at a commit, and we'll just leave it. Not to say that it can't move, but by convention, we probably won't move it. Cool. So these were all local branches. Let's talk about remote branches. Now, here's where, yeah, I probably want to clone from GitHub or from Bitbucket, but instead, let's open a new terminal over here. And let's go up a folder, and let's make a directory for the server. Now, last time we did git init, let's do git init again. But instead of just git init, we're actually going to pass in another flag, --bear. And what bear says is instead of creating a .git folder and all the contents in it, just create the contents without the .git folder. So we have all of those same files, but not in a folder. This is perfect for a server environment where we want to be able to take a look at our content, but not have to have a checkout directory. So let's go over to our server. We'll come over here to the server folder, and there's the contents of the .git folder, but not the .git folder. We have no checkout directory. That's perfect. Okay, so let's rig this up. Git remote -v. I have no remotes yet. Great. Let's git add remote. I'll call this one origin. We could call it trunk. We could call it server. We could call it Susie's machine. And then the path to it. github.com/robrich/ blah, blah, blah. Or we could pass in a server name, my server path to folder. Or we could do it locally, c:/my machine/foo. But in this case, I'm just going to use a relative path. I'm going to go up a directory into the server folder, and that will be my remote. Server, git remote add origin. Yeah, putting them in the right order makes a whole lot of sense. Git remote -v. So now I've rigged up my server. Now here in the server, in our local one, we have lots of objects. And in our server, we have no objects. Okay. Well, let's send some objects to the server. Git push origin main. I'm going to send the main branch, and now all of that main branch content ends up on the server. So now our server has a lot of stuff. Now in our .git folder, git log --one line --decorate --all, we now have this origin/main. Well, how does that work? Well, here inside refs, we saw heads and we saw tags, but we now have remotes. Now, I have only one remote. It's called origin. And inside origin, I have a main, and it points there. That's where I think the server was last time I looked. Now, right now, the server only knows about main, so let's push some other things. Git push origin, new branch, and tags. And so now all the rest of the content will go to the server, and I now have new branch in my remotes as well. So remotes, so refs, these are just name tags, ways that we can associate it a bit better than that really long GUID that gives us the details there. Cool. We looked at logs and refs, which is really cool. That's a great way to be able to go find where we were, and we'll have one for each of them. Now we have remotes, and we could wander through where our remote branches have been as well. And next, let's take a look at hooks. Now there's a whole bunch of hooks here, and if we open each one, we can take a look at them. This is a shell script, another shell script, a Perl script, and these are all samples. If we just remove the .sample, then that will run that script. So I'm going to go reach into my tool chest, and I'm going to go grab the hooks that I've got, set them in place here in my repository. And I've just now created a shell script, which is just going to say, here's the thing, and here's the parameters that you pass to it. So I have one for this one and one for this one, and that will just help us see hooks. Hooks are a great way to do automation. So I'm going to create another file, echo file 5, and redirect that to file 5, git add all the things, git commit -m file 5, and we can see the pre-commit hook, the prepare commit message hook, it passed in the message, the commit message hook, if we were to git push origin new branch, then we can see some more hooks. If you've ever pushed with Kudu to Azure, or if you've ever pushed to Heroku, you know how it does stuff? It kind of gives you messages. It has a server receive hook that is just kind of doing interesting automation. So I could do interesting automation. Maybe I want to, on stage, run linting right before it stages. Or maybe I want to validate that my commit message matches our corporate standard so that we can automatically generate release notes. Or maybe before I push, I want to run all my unit tests and validate that those pass. I can do all these things inside of these hooks. I just run a shell script, or a Node app, or a .NET app, and I can just run it. So hooks is a great way to do that. I've created all these hooks, and so I want to say git add.git/hooks/commit git status. I can't commit content in my .git folder to my .git folder. Bummer. Okay, now the hooks are only on my machine, so yeah, I'll run all the unit tests, but good luck for you. How do we get these hooks outside of the .git folder so that we can be able to share them with our team? Well, there's lots of different tools that we can look at. If we're inside Node, Git hooks is great because not only does it automatically wire up symlinks or junctions inside of Linux or Windows respectively, but it also adds on install, it automatically rigs up those things, and it creates this hooks directory outside of the .git folder. If we're in other systems, we might want to use pre-commit. That's in Python. PHP has PHP git hooks or grum PHP. There's git hooks written in shell. Git hooks in Go is actually a clone of the shell script. The C# community uses the Python one. Or you could just run this config to set your hooks path to some other folder. But again, that config is machine specific. So it may make more sense to, say, use git hooks or Husky. So that will get our hooks directory outside of the .git folder so we can now commit it and make some really interesting things. So we took a look at hooks. That is great for automation. I'll just leave all my hooks in there. That'll be fun to find as we wander through. We got to look at refs, objects, logs. Let's take a look at exclude. Now here in the exclude, I might choose to say exclude node modules, package lock.json. We can fight over whether we should exclude or include that later. And .env. Hey, wait, this looks like a gitignore file. Yeah, this is a gitignore file inside the .git folder where I can't commit it. So let's not put this here. Yeah, there is an exclude a gitignore file inside the .git folder, and that's the exclude file. There's also a bunch of temp files. This commit edit message is the thing that it passed to that commit hook, so the commit hook might be able to modify that message and do interesting things. We could find other temp files here as well. Sometimes you'll find merge files about halfway through, which is really interesting. Index. Index is really interesting. It is a binary representation of the hashes of all of the things in your working directory before you change them. You know how you say git diff or git status, and it says, hey, here's all the things, and then you can say git diff, and it runs really fast? Well, what it would typically need to do is it would need to say, okay, I'm right here. When's the last time you committed that file? Let me grab that version and diff it with, and so it kind of has to crawl the entire tree. So instead, we have this index that is kind of nice. It just keeps track of it. Now, if you wanted to wander through it, here's a really excellent Stack Overflow post that details the exact status of each byte in the thing, which is just amazing. Or you can use this Python program, Gin, to be able to read this thing. Or actually, what's really fun about this thing is there is git ls files -- stage, a command that you can just run and it will do that. So this will go look at that index. Here is the hash of all the files committed in the working directory at this checkout. So if I modify a file, it can hash that file, compare it to the hash here, and it knows if that file has changed. It's a really cool cache to be able to just quickly run that status and diff algorithms. That is this index. Description. Git InstaWeb. Git InstaWeb is a built-in web server that runs inside of every version of Git except for Windows and launches your Git repository as a web server. You've probably never used it because we use all the servers, GitHub, GitLab, Bitbucket, SourceForge, and so we don't run our local stuff as web servers. But if you happen to do that, as it enumerates all of the repositories that you've chosen to host, you can put a description with that in Git InstaWeb, and the description is stored here. Wow, I don't care at all. Git InstaWeb. It doesn't work on Windows, but that is really interesting. The last file we're going to look at is right here, the config file. Now this is an INI file. Did I just trigger anyone? But the cool part is this INI file, this config file, lists all of the settings that are specific to this repository. Now this overrides any things in my system one, which let's go open the recent one right here. This is my user profile one that gives me all kinds of specific ones. Why is the user specific one called global? You know when you said git config -- global? It's because you were setting the things in this file. Well, that's kind of cool. But this one overrides all the options that I did when I installed Git. And so that one, in my case, is in program files. And here's all the options that I picked when I installed Git. Now, you probably don't want to change this one, because when you install Git again, or if you install updates, it might override this. And so I'm not going to change the system one. Instead, I'm going to change the global one, the user-specific one, it's global to all my repositories, I guess. Thanks, Linus. Or I could change them here in my local one. So let's imagine that I've got a whole bunch of work projects and I've set my git config globally for my name and email, and I want to change that for my open source projects that I want to run in this directory. So I can go grab the settings that specify my name and email, and I can change them in this repository to be something else. I now have updated the commit details for this repository. So if I create a new commit, let's go git echo file 6. Uh-oh, they found me. Git add file 6. Git commit -m file 6. Git log. Oh, we've got some hooks. Woohoo! Automation for the win. And you notice that the previous commits were to robrich@robrich.org, but this one is to robrich@corporate.com. We changed that setting specific to this repository. Now that's cool. We can change lots of settings. One of the things that I like to set is the default branch name. Now, by default, it is master. But I don't want it to be master. I want it to be main because Black Lives Matter. And so I'm going to very specifically say, when I create a new repository, I want the default branch to be main. And I can set that setting here. Or I can create some interesting things. I've defined my merge tools and diff tools. And one of the things that I really like, help autocorrect. This is the number of tenths of a second it will do. It'll wait to show me that I screwed up. So it's not uncommon for me to say git log, and it's like, hey, oh, not that one, git stas. And it's like, hey, did you mean status? Why, yes, I did. Thank you for running that automatically. The other thing I do is I start typing a git command, and I kind of get distracted. And then I come back and I say, well, I would like to run git status. And so I have an alias for that. Let's talk about aliases really fast. I have various aliases that allow me to run commands shorter. So we did git log --one line --graph --decorate --all. I've created a shortcut for that, git hist. Now I've rigged up that shortcut because I created this alias that says hist means that. And so I have this alias that says git, and it means start a new shell and run git. So I can run git status, and by the way, it works just fine. Aliases are awesome. So that was the last file that we got to look at here in the .git folder. We got to see how we stored our objects as commits, trees, and blobs. We got to see how we created refs that identified branches, tags, and remotes. We got to see logs where we keep track of things like the ref log so that we can get out of a detached headspace, or if we accidentally deleted the branch name. We saw interesting things in info like please don't write your .gitignore file here. We saw automation where we can run unit tests or linting or whatever we want to do either before or after we push, before or after we commit. And we saw some interesting things including the config file that allows us to be able to do really interesting configuration. Now these definitely aren't the only commands in Git, but what's really cool is you can head out to this page if you would like to read and learn each of those pieces inside of this repository to do interesting things. Or a good friend of mine, Eric Potter, actually built this infographic that does similar things. And all of that is available right here on this gist that allows you to be able to wander through everything that we saw today. This content is online right now. Go to robrich.org, click on presentations, and you can see that content. Thanks for coming.